Hello everyone, welcome to this video. In this video, we'll be solving this question which states that we have to consider this element A, which is nothing but 2 cross 2 matrix which has been taken from the special linear group consisting of all 2 cross 2 matrices having entries from the set of real numbers, right? So it contains all the matrices having the determinant as equal to 1. So obviously the determinant of A is also equal to 1. Now they are asking to you in the first part that what is the order of this matrix A. So you know, if you remember the definition of order of some element, here you know what is the group operation. It is matrix multiplication. So for matrix multiplication, right, what is the order of this element A? It is obtained when you take the powers of A, and at any time if it becomes equal to the identity matrix having order 2, right, because its determinant you know is equal to 1, therefore then we will call that power to be the order of the matrix A, right? So here the matrix A is given to be this. When you take A square, it is not equal to I. When you take A cube, it is also not equal to I, right? This is a similar matrix that we have solved in the previous video as well. If you take A raised to power 4, it is also not equal to the identity matrix, right? So but you can observe a thing that when you take power 1, you have 1 here. When you take power 2, you have 2 here. When you take power 3, you have 3 here. When you take power 4, you have 4 here, right? So you can generalize it in this way. When you take n power, it would be n here. So for no power here, you get the number 0, right? So that is the case. So what does it mean? It means that we never get the identity matrix in this particular case. Hence the order in this case of A is not defined, correct? So this is one part of the question. In the next part of the question, they are asking to us that if we take the same matrix here, but now as a member of this group, special linear groups having which is consisting of all 2 cross 2 matrices whose entries has been taken from ZP. What is ZP? It is the set of integers consisting of all the elements from 0 to p minus 1, where p is some prime number. So in that case, they are asking what is the order of A. So here let's answer this question. Now you know, we know because by the above argument, because an is equal to 1, n, 0 and 1, right? So this would imply if p is prime, we would have also a raised to power p is equal to 1, p, 0 and 1. But now we are doing the calculation under mod p. Why? Because we are in the group ZP. So here the calculations are performed under mod p. Hence we have a raised to power p would be equal to 1. Now what is p mod p? P mod p is actually 0. Why? Because when you divide p with p, it goes exactly right on p, hence you get the remainder as 0. So 0 is the answer in this particular case, correct? So therefore you have 0 here, 0 and 1 here when we are doing the calculation under mod p. So what is this? This is the identity matrix now. Now if this is the identity matrix, so that means we obtain the power p such that you get when you take a raised to power p, you get identity. Hence the order of A is equal to p when p is prime, correct? When p is prime and this A belongs to the special linear group consisting of all 2 cross 2 matrices whose entries have been taken from ZP, correct? And what is the role of prime p here? Because you do not have any other number which is divisible by this p. Hence in this particular case, you have p as the order because you do not have any other smaller integer which follow this property. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.